Part A, amplitude perpendicular to direction of motion. Pulse. Do it again, bigger. Direction of amplitude parallel to the direction of motion. Does the size of the amplitude affect the speed of the wave? Does the frequency affect the wavelength? Slow, fast, stop. Now we're testing to see if pulses bounce off each other or pass through each other. 1, 2, 3, go. 1, 2, 3, go. Now we're testing interference with two pulses of about the same size on the same side of the spring. 1, 2, 3, go. Now we're going to zoom in to the point where the pulses meet. 1, 2, 3, go. 1, 2, 3, go. Now we're going to test what happens with interference when the amplitudes are on the opposite side of the spring. 1, 2, 3, go. 1, 2, 3, go. Now we're testing to see which side the pulse returns or is reflected from a rigid medium. Now we're going to see what happens to an incident pulse that hits a less rigid boundary. Bigger.
Oh.
This is reflection from snaky to slinky and slinky to snaky. First, we will look at the reflection in the snaky. Okay, now we're going to have reflection from the slinky sent to the snaky. There we go. Bigger. That was perfect. Okay, this is what happens to a pulse on transmission. So we're going to go from slinky to snaky. Now we're going to go from snaky to slinky. Okay. Now we're going to test the speed of the pulse in different media. 1. Now we're going to see what happens to the wavelength when a wave goes from one medium to the next.